All right, so in this mini lecture, we're going to talk about properties of exponents. First thing to know is what an exponent actually is. So it's also maybe called a degree or a power. An example would be something like x to the fourth power. The base is the x. The 4 is the actual exponent. What does this mean? X to the fourth power, it means X is being multiplied times itself 4 times. So it's X times X times X times X. And that's the basics of an exponent. Now we're going to go deeper and look at properties of exponents, which will come up very often in algebra and college algebra and other classes in math that you take beyond that level as well. So let's go ahead and get started. All right, so the first rule is known as the product rule. So you may see it looking something like this. It's in this general form of a to the m times a to the n power. Now here, understand that the bases must be the same. And in this form, they are, right? They're both a's. Now we can change those in an example, and I'll show you how they could be x's or they could be sevens or something like that. So once we understand that it's in this form, we go ahead and apply the product rule. So what happens when you see the bases being the same and the exponents being different and it's a multiplication problem? Well, you go ahead and add the exponents. So we say m plus n. So here's our example. Our example could be x to the fourth times x to the third. Well, what do we do here? We go ahead and add the exponents, 4 plus 3. So this gives us x to the seventh power. So again, the bases must be the same. If they aren't the same, then there's nothing else that we could have done to the problem. However, they were the same. They're both x's. All right, the next one is the quotient rule. It will look something like this: a to the m over a to the nth power. All right, so what happens here? As long as these bases are the same, we go ahead and subtract the exponents. We subtract the exponents. So here's an example. The example may be something like x to the, let's say, sixth power over x to the second power. Well, the bases are the same. They're both x's. So we say x to the 6 minus 2, and that gives us x to the fourth power. And you always subtract the bottom from the top, or we could say top minus the bottom. No matter what the signs are, you use those signs, or how large or small the numbers are, you use those numbers, and it's always top minus the bottom. And the next property of exponent, this one is called power of a power. So here we have some base raised to a power, and that entire thing there is raised to another power. So how do we attack this? We go ahead and multiply that exponent on the inside times that other exponent, or the power that we're raising it to. So we multiply the m times the n. Let's look at an example. Let's say if this said x to the fourth, and this was raised to the second power. Well, we would go ahead and say x to the fourth times 2, and 4 times 2 gives us 8. All right, another power rule, we'll call it power of a product. Power of a product. So here we have a product within the parentheses, and that's raised to the mth power. So here's what we do. We're kind of like distributing this m times all of these exponents. And you're saying to yourself, what do you mean these exponents? Well, a has an invisible 1 as an exponent, and so does b, right? B has an invisible 1 as its exponent. So m times 1 makes it a to the mth power. B, m times this 1 here makes it b to the mth power, right? Because I basically just distributed this m times the invisible exponents, the implied ones that the a and b have for exponents. So let's go ahead and take a look at an example. Let's say we had something like 5x to the third power, right? And this whole entire product is raised to the second power. Well, we would make this 5 to the second power, and that's times x to the sixth power. Well, I'll say 3 times 2, right? I'll write it out. So that gives us 25. 5 to the second power is 25. 3 times 2 makes this x to the sixth power. So we get 25x to the sixth power. All right, now looking at one of the negative exponent properties. We have here a to the negative m. So in this property, we're saying to ourselves, whenever there's a negative exponent, that's something we don't want. We want to always try to get rid of negative exponents. Right now, this a is actually really in the numerator, right? We just don't write it as a to the negative m over 1. However, we could if we chose to. So knowing that it's in the numerator right now, we want to bring it down to the denominator. And when we do so, it becomes positive. So it becomes 1 over a to the mth power, right? So all we did was bring this base and its exponent that's negative down to the denominator, and it becomes positive. So let's look at an example, x to the negative fourth power. So it's in the numerator right now. All of that is actually kind of like saying it's over 1. I just didn't write it like that. We just didn't show it like that. So if we bring it down to the denominator, it becomes x to the fourth power. So once you bring it down, the base and the exponent that's negative down from the numerator, it automatically becomes positive. And this second negative exponent rule, I'm going to start out with it being negative, the exponent, while it's in the denominator. So what do you think happens here? Exactly. We're going to move it to the numerator. Once we move it to the numerator, it becomes positive. So it looks like for these two negative exponent rules, if you have the base and a negative exponent in the numerator, we move it to the denominator, it becomes positive by mathematical rule. If we have a negative exponent and its base in the denominator, we move it back up to the numerator and it becomes positive. So let's look at an example like this, 1 over x to the negative third power. Well, I don't want a negative exponent. It's currently in the denominator, so I'm going to move it up to the numerator and it becomes x to the third power. And then here's my final property of exponent. This will be called the zero exponent property. So here it looks something like this, where we have something raised to the 0 power. So how do we apply it? Well, whatever is raised to the 0 power is always equal to 1. So let's say if we had the quantity of negative 5x, all of that in parentheses, meaning it's together. So all of that is raised to the 0 power. What's the answer? It's 1. We could have z to the 0 power, it's 1. We could have 1 trillion to the 0 power, it's 1. All of those make 1. There's one exception, which is 0 to the 0 power, which is known as undefined. Right, so what we've just covered were properties of exponents. I did the examples where I showed each property of exponent, but later on, what you may have to do is be able to combine those properties of exponents when you're simplifying an expression with multiple properties that need to be completed. All right, so feel free to share the video with others who may be in need of it. Please like the video if it helped you any and subscribe to the channel. Take care. Have a good day.